Hi, my name is khokho emmanuella claudia. I am a student of University of Mara from Cameroon. I am very glad for this opportunity offered to me by the Center for High Performance Computing to be able to participate in this conference. The title of our presentation is presented on this slide. This work was done under the supervision of Professor Changwanya Fridolin of the University of Mara in Cameroon, Dr. Malim affiliated to the University of Mara, as well as the University of South Africa, and Professor Janet Korondi of the University of South Africa. Our presentation plan consists of an introduction, methodology, results, and conclusion. So, nowadays, the fabrication of electronic devices based on organic compounds is the focus of research. Organic compounds are used to design lighter televisions, more flexible solar cells, transparent and design flexible displays as shown respectively in figures A to D. Figure 1 shows two organic molecules having carbon and hydrogen as elements. In the literature, these molecules have been synthesized and classified as organic semiconductors. The gap energy is the parameter on which one plays to be able to improve the conductivity of a molecule. They propose to improve this energy value. For that, they made a total functionalization by chlorine atoms. With the functionalization, they showed that the gap energies decrease suitably compared to that of the basic molecules. In order to improve the gap energy values and many other parameters, we propose to make a partial functionalization with 1 and 2 potassium atoms of the base molecules. The partial functionalization of the base molecules involves the substitution of 1 and 2 hydrogen atoms by potassium atoms at favorable positions. To carry out our study, we will work with quantum methods. These methods are the result of the approximate solution of the Schrödinger equation. More precisely, we use the density functional theory (DFT) through its hybrid functional HSE, which is the High-Scazeria and Zeher functional. The HSE has been associated to the 6 to 31 gene, which is a basis introduced by Poppel. These methods are implemented in Gaussian 16, which is the main tool used to generate our output files. The larger a molecule is, such as our case, the more it requires tedious calculations. The Center for High Performance Computing, thanks to its supercomputers, allowed us to have in a few days the calculation that would take months in our classical machines. Results. Figure 3 shows the optimized structures of the study molecules. Figure 4 represents the highest occupied molecular orbital HOMO and lowest unoccupied molecular orbital LUMO and the gap energies of the study molecules. The values of the gap energies found for the basic molecules are in agreement with those found in the literature. The derivative have smaller gap energies than the base molecule, which makes them better semiconductors. Table 1 allows us to evaluate the nonlinear parameters of the molecules. The parent molecules are centrosymmetric because they have a zero dipole moment as indicated in red on the first line. The derived molecules have the highest values of the first order hyperpolarizability, which are higher than one of the paraneutrinaline molecule given in the last column and which is used as reference in nonlinear optics. The derived molecules can therefore be used in nonlinear optics for the fabrication of optical sensors, signal transmission, and many others. We present in Table 2 the absorption wavelength and the photovoltaic parameter of the molecules. The parent molecules have a wavelength in the ultraviolet range. On the other hand, the derived molecules have their wavelength in the visible range, which is already an advantage for their introduction to photovoltaicism. The effective harvesting of light (LHE) parameter is the parameter that allows to certify that a molecule can be used as solar cell. The LHE values of the derived molecules are big in front of the basic molecules. Hence, the derived molecules can be better used as solar cells. Conclusion: we can retain that we can modify the properties of a molecule to make it multifunctional. The resources submitted to us by the Center for High Performance Computing has helped us to progress very quickly in our research. We sometimes encounter difficulties in the complete execution of some calculations, particularly with the semi-empirical methods that are very heavy to implement, and we question the Center for High Performance Computing to review the time factor of execution of calculation in relation to the implemented methods. Thank you for your kind attention.